most simple method in our work, like we can call it the k-neighbors regressor, because our problem is a regression problem in which we have X of data that needs to predict a Y value. So to do so, we need to import the needed libraries, but before that, let us actually understand how these values work, or how these methods work. So the KNN, or k-nearest neighbors, is an algorithm that can be used for both classification or regression. To understand the regression, which we are interested in this example, we have to first understand the method that is for classification. And the way it works is basically you have these data already, or these clusters for these data already, assigned. For example, you can see 1, 10, 2, 3. These are the number of data, or the data classes, and you can see these different colors are different classes. And now we have, for example, a new point, this black point, and now we want to consider this point, where it is located. So from this point, we see our neighbors. So as the method says, k nearest neighbor, so the k is how many neighbors you want to consider for classifying the new points. And you take this point, and based on these already made clusters, you assign the point which is the most neighbors they are close to it. So in this case, for example, this point, you can see that most of the neighbors that are close to it is this place. For that, we actually use this as we can consider this black point into class number 3, which is this dark green. Now, how to build this, basically this map, is the training process. The training process, we already know the classes, and we build a principal, like in this case, a principal component. We reduce the dimensions to build such map. But the main thing is we build these clusters, these classes, and we measure the distance from every point to these classes. And of course, the measurement will be used not, of course, on PC, on principal component, but by actually measuring the distance of this point feature to the other neighboring points features. So of course there is a lot of math behind it, but what we need to understand is always take the point and measure the distance to its neighbors to classify this point. Now, what about the other situation? What if we want to not use the k nearest neighbor to cluster, but actually to nearest neighbor to classify the point, but actually use this point for regression? For regression, what we do is we take this point, and again, for example, the point of this 11, ID 11, what is we need to know what is the regression value of it. The same thing we have is we take this point and we look for their neighbors. For example, we have this example that we have points from ID 1 to ID 11, and we have the height and age, and there is weight. So we have the X is height, X1 is height, X2 is age. These are the X data, and the Y data that we need to predict is the weight, which is going to be our Y. Of course, in this case, we can directly plot it, and we have the height and the age, and now we will ask ourselves what is about point 11, what is the value of the weight of point 11. So we take we can assign these values on this map, and then we measure the distance, which are the closest points, assuming that k is equals 3 and k is how many neighbors we want to consider. Of course, we can consider more than 3, like we can consider even much more, but let's consider 3 reasonable value in this case. So we can see point 11, and which are the closest point? It's 1, 5, and 6. And so to predict the value of point 11, we simply we simply just sum the points of the neighbors and then divide by the number of them. And in this case, 69.66 kilogram. So going back to our code, we can now start to write this code that use the KNN, k nearest neighbor. So to start with that, let's first import time, and from time is going to be used for we want to calculate how much time every method is going to cost us. So from import time first, and then from sklearn we will metrics import the mean squared error. And of course, the mean squared error is our method of measuring how good our solution is. So we will import this one, and also from sklearn dot neighbors import KNN neighbors regressor. So sk neighbors import k neighbors regressor. Okay, just put them up there, and as we said, it's better to have all our imports over here, and we go down and we now start using it. So let's write now the code that we will take this k neighbors, and we paste it like we have the x train as an input and y train as the thing we need to predict, and of course test it on x test and y test, or x test max in our case, and y test. So the first thing is we start from here. Just we give it some time. So here we can start equals time dot time. Of course, this is the starting time. We will record the time, and the model equals k neighbors regressor. The number of neighbors is equals 9 dot fit, and of course the input is going to be x train, y train. Now, as simple as this, this is the only line we need. This is the beauty of sklearn, scikit-learn, that we actually just one line we already trained the model. Now y prediction here we predict our value dot predict. So we use this model to predict what? X-test. So X-test, and we'll end or just end equals time dot time. We bing the time again, and calculation time will equals the start time minus the end time, because we can call it, maybe start time is better, but it's okay. And of course we need to print out first calculation time, and take this one and in seconds. And root mean square. And root mean square have to be squared error y test. This is that we 100% know it's correct, and y predictions. Here we close everything and we run it. We have, I think it's a syntax. Yep, it's done, but actually it should be end minus, of course the end time should be minus the start time, just to remove this. So here we can see that the root mean square is quite high actually, and the time it took is this much. To plot it, we just plot the prediction versus the actual number, and I already have a ready code that I will just paste it in here, so you can pause a bit and actually write this code. It's basically just a code to make the plot looks beautiful. So you can see here, so this is the first thing is we need the sizes of the the size of the fonts we're using, and below we can see the actual plot annotation. This is just write some statement on the actual plot. So let's run this one, and here we can see the actual and predicted and how they are correlated. So not so bad I would say, but a bit here, these like these points in here has quite far from the center. Another plot is to plot our result in X and compare it like RUL with number of engines, and you can see is actually not that bad. As you can see, many values, sometimes they are overlapping between these two lines. So you can see the the actual is the gray and the predicted is the blue. Sometimes here it's quite far, but some engines are having more reasonable values. So some predictions here, they cause us actually a high root mean square error.